So in this video, we're going to be looking at some examples of using the Pythagorean theorem to find the distance between 2 points. So for number 1, I want to use the Pythagorean theorem to find the distance from D, which is the point 3, 4, to E, -2, -5. So again, like we saw in our previous video, the distance is really the same thing as length. So really this is asking us to find the length of DE. And we'll see here that, remember from the Pythagorean theorem, that we want to do the legs squared added together, and that equals the hypotenuse. However, I don't really have a rectangle, or not rectangle, we have a triangle here. And so we can actually create that. And to do that, I'm just going to do a dashed line all the way down to where this point is at, and then do a dashed line here. And so I see this actually creates a right triangle because it comes at a corner like that. And so now I can actually label how the distance or the length of this side and this side. And I can do that by counting, since this is just a horizontal line and this is a vertical line. So I see here, this is going to be 1, 2, 3, 4, 5 units long. And this side is 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. And so I have my legs, because remember the legs are the sides that are connected to this right angle, and I want to find my hypotenuse, which is just going to be labeled as C. And so I can use my Pythagorean theorem. So I have a squared plus b squared is equal to c squared. A or B, these can be either or. I'm just going to do the smaller one as my A, so that's going to mean that this becomes 5 squared plus 9 squared is equal to c squared, where c is just the length of my hypotenuse. 5 squared, I get 25. 9 squared, I get 81. And then I need to add 25 and 81, so when I add up 25 plus 81, I get 106. It's equal to c squared. Now I want to get rid of that square there, so I can just have c by itself. And if you recall back in our previous unit, the inverse of square is actually the square root. So to get rid of that square, I'm just going to take the square root of it. I'm going to take the square root of both sides. And now, with all of these answers, I want to write these in simplified radical form. And so going back to simplifying radicals, there are a couple of different ways that you could do it. I'm going to go ahead and just for these examples use that factor tree. And so I can see that since this is an even number, that 2 can go into it. So I have 2, and when I divide 106 by 2, I get 53. And now I need to see if I can break apart 53. Well, 53 is not an even number, so 2 can't go in it. 3 can't go in it, and so on. You'll actually see this is a prime number. Nothing goes into 53. So I don't have any pairs that I can take out. So that means that my c equals the square root of 106 is actually in its simplified radical form. And so that means that the distance from D to E, or in other words, the length of DE, is equal to the square root of 106. Let's look at another one. So here I want to find the distance from R to S. So my first step is to go ahead and create that right triangle. And so I just like to do it from the bottom. You could go up from the top and go forward. I just like to go beneath it and make my right triangle. So this bottom, this is going to be 1, 2, 3, 4, 5, 6. And this other side is 1, 2, 3. And I'm wanting to find what the length of RS is, and I can just label that C for now. And I'm wanting to use Pythagorean theorem, so this is going to be a squared plus b squared is equal to c squared. Well, a is just 3. You can also use 6, doesn't matter which one you do. I'm just going to have a be 3, b be 6, equals c squared. Well, 3 squared, I get 9. 6 squared, the same thing as 6 times 6, which is 36. And then 9 plus 36, I get 45. Now again, I need to get rid of that square on there, so I'm going to take the square root of both sides. But now I need to write this in simplified radical form. And so I'm going to go ahead and break this apart into its prime factors. I see that it ends with 5, so I know that 5 goes into it. And when I do 45 divided by 5, I get 9. So 5 times 9 gives me 45. And then 9 can be broken up into 3 and 3. And so I see that I have a pair of 3's that come out. And so when I'm writing that in simplified form, since I have a pair of 3's, that means a 3 comes out. And all I'm left with in the under the radical is my 5, since it did not have any pairs. So that means that the length of our S is equal to 3 square root 5. Okay, looking at this last one, first step is to create a right triangle. So I'm going to use my dashed lines here. And then find the lengths of these two sides. So this one is 1, 2, 3, 4, 5, 6. And this one is 1, 2, 3, 4, 5, 6 as well. And my Pythagorean theorem says this is going to be a squared plus b squared is equal to c squared. Again, my a and my b are my legs, so that's going to be the 6. Okay, go ahead and pause the video. I want you to finish out this problem. When you think you have it, go ahead and press play. So the answer you should have gotten was 6 square root 2. So in the end, you should end up with 72 that you're taking the square root of. Again, I used the prime factor tree to reduce this, and I saw that I had a pair of 2's and I have a pair of 3's. So that means a 2 and a 3 came out. But since I had multiple things come out, you need to make sure you multiply those together. So 2 times 3, I get 6. You also could have recognized, another way for doing this, you could have recognized that 72 is the same thing as 2 times 36, which is square root of 2 times square root of 36. And then the square root of 36 is just 6. And so you still end up with that same answer.